In the next four exercises, we're asked to take each quadratic equation or function and find the vertex of its graph and determine whether that vertex represents a maximum or a minimum value for the function. In 64, we have an equation in vertex form: y equals a times x minus h squared plus k. And for this, the vertex is explicitly given in the equation. So the vertex is the x value is the number that's being subtracted from x, so that would be -4, and the vertex y value is k, the number that's being added to the outside. So the vertex is 4, 7. Because a is a number that is a negative, that means this particular graph that has its vertex at the point -4, 7 will be a graph that will open downward, and so that vertex is going to represent a maximum value for that quadratic function. In 65, we have a function that is written in factored form, which is y equals a times x minus r1 times x minus r2. So r1 and r2 in this case are the intercepts of the graph. So if I were to draw a graph, the intercepts would be -4 and 2. And by intercepts, I'm talking about the x-intercepts or the zeros of the function. So those are going to be the x-intercepts or zeros of the function because they will be the values that will make y equal to 0. And so that means that our parabola, I've drawn it the wrong direction, will be opening upward. And the reason it's opening upward is because a is a positive number, 2, and the vertex x value is halfway in between those two x-intercepts because a quadratic function is symmetric. Now, you can draw the graph and eyeball that number, but you can also find it by averaging the x values of the intercepts. We want to find the value that's halfway in between them. We're going to add them together and divide by 2. So that gives us -2 divided by 2, which is -1. So -1 is the x value, and the y value for that vertex is 2 times -1 minus 2 times -1 plus 4. Just replace x with -1 in the equation, and you can compute the y value, and that'll give us -3 times 3 times 2, which is -18. So our vertex is the point -1, -18, and it represents a minimum for that function since the parabola is opening upward, and that will be the lowest point on the graph. In 66, we have an equation that is in standard form: y equals ax squared plus bx plus c. And in this case, the vertex is located at x equals -b divided by 2a. And -b would be +10, and 2 times a would be 2 times 1, so that's 10 divided by 2, which is 5. We can find the vertex y value by replacing x with 5 in the equation. So that's 5 squared minus 10 times 5 plus 29, which is 25 minus 50 plus 29, and that result should be 4. This tells us that our vertex is located at an x value of 5 and a y value of 4, and since the a value for this is +1, that means that our parabola is going to be opening upward, which means that vertex is going to represent the lowest point on that graph, so that would be a minimum value. In number 67, we have another factored form here. So y is equal to -1/9 times and we can rewrite x as x minus 0 if you wish, and that's the factored form y equals a times x minus r1 times x minus r2. And so that means the intercepts of this graph are 0 and 6. So 0 and 6 are the two places where this graph meets the x-axis. And since the a value here is negative 1/9, then that parabola will open downward. And if that opens downward, then our vertex is going to represent a maximum value. So how do we find the x value of the vertex? We're just going to simply average 0 and 6, and we're going to get an average value of 3. You can add them together and divide by 2 if you wish. To get the y value, we're going to get that from the equation. So in the equation, y is equal to negative 1/9 times x, which is 3, times x minus 6, 3 minus 6, and we'll just do the computations here. Negative 1/9 times 3 times negative 3, so that's negative 1/9 times negative 9, which is 1. So our vertex is the point 3, 1, and that's going to be a maximum point on that function since it's the highest point on that graph. In 68, the height of a ball thrown in the air is given by h equals 30t minus 5t squared, where h is the ball's height above the ground and t is the time after the ball was thrown. So I'm going to rewrite this in standard form. H is really kind of like our y in the standard form equation, and t is like our x. So h equals negative 5t squared plus 30t plus 0 when written in standard form, and c is explicitly given. And so the maximum height is going to be at the vertex of this parabola. So if we were to graph the height function, it's going to be an upside down parabola because our a value is negative, so we know that the vertex is going to represent a maximum value. And the time at which the ball reaches the maximum height will be negative b divided by 2a, which is negative 30 divided by 2 times negative 5. So that's negative 30 divided by negative 10, which is 3 seconds. And then that maximum height can be found by replacing the t value with 3. So the height is equal to 30 times 3 minus 5 times 3 squared. And so that's 90 minus 5 times 9, which is 45. So that's going to be 45. So the time at which the ball reaches its maximum height is 3 seconds, and the maximum height is 45 meters. We need to look carefully at the units that are given to us. It said the heights were measured in meters and the times in seconds. In the next set of exercises, we're asked to write and solve to answer each question. So we're writing an equation, and this is one having to do with the time that it takes for someone to do a job with someone together. And so let's remember what our formula is. 1 over the time of one person alone plus, so I'll call that T1, plus 1 over T2, that's the time of the second person alone, equals 1 over T3, which is their time together. All right, so one pipe can fill a tank in 24 hours, and another can fill the same tank in 36 hours. How long would it take them to do the job together? So the time together is the missing piece here. So we can take this equation and multiply both sides by the least common denominator, which is 72 times t. And remember, we've got to cancel all of those denominators out when we multiply together. So that's, multiply the first fraction times 72t, we're going to get 3t, and the second fraction by 72t, we're going to get 2 times t, and 1 over t times 72t is 72, so 5 times t is 72, and dividing by 5 goes into 70 14 times with 2 leftovers, So we've got t equals 14 and 2/5, and that would be measured in hours. Let's give that in hours and minutes. So that would be 14 hours, and 1/5 of an hour is 1/5 of 60, which is 12 minutes. So 2/5 is 24 minutes. Number 7 is similar to the previous problem. Eric can do this job, icing cupcakes, in 10 minutes, so 1/10, plus 1/Kate's time. But here's this thing about this problem. We don't know Kate's time, so I'm going to leave that one as 1/T, and that's equal to 1 their time together, which is 6 minutes, because it says if Kate helps, then it takes them together 6 minutes. We're going to multiply both sides of this equation by the least common denominator, which is 30 times t. So 30 times t times 1/10 is 3t, and 30t times 1/t is 30, and 30t times 1/6 is 5t. So I'm going to subtract my 3t, and we get 2t equals 30, and t is 15. So it's going to take Kate 15 minutes if she were to ice the cupcakes herself. In 71, we have a direct variation question. On planet Q, the time it takes for an object to fall varies directly as the square root of the distance it falls. So I'm just going to write an equation from that. Time varies directly, so equals k times the square root of the distance that it falls. Now we have some other information that's going to help us find the value of k. So the object is dropped from a height of 4 feet, so that means the distance is 4 feet, and it takes 6 seconds to hit the ground, so that means that t is 6 seconds. And so now I can solve that equation for k. So square root of 4 is 2, so 2 times k is 6, and k must be 3. That means that the equation of variation for this relationship is t is equal to 3 times the square root of d. Now that we have that equation, we can find how long it will take for an object that's dropped from 25 feet, so replace distance with 25, to hit the ground. So t is equal to 3 times the square root of 25, or 3 times 5 is 15, and that would be measured in seconds, since times are measured in seconds in this exercise. In 72, suppose that m varies directly as t. I'm going to write that down. M equals k times t, and inversely as p, so divided by p. That's a relation of m with t and p in the same equation, so m depends on multiple variables. Now, we do know that m is 10 whenever t is 5 and p is 4. So we can multiply both sides by 4. That'll give us 40 is equal to 5 times k, and k must be 8. So that tells us that the relationship here is m is equal to 8t divided by p, and we're asked to find m whenever t is replaced with 12 and p is replaced with 8. And so 8 times 12 divided by 8 is just 12, and so 12 is our answer there.